To measure the speed of an object, we're going to use a linear air track. The lightweight aluminium vehicle glides on top of a stream of air. It's a smooth, almost friction-free journey. Average speed is the distance moved divided by the time taken. To measure time and distance accurately, light gates are placed 1.5 metres apart and linked to an electronic timer. A beam of light shines from one side of the gate to the other. As the beam of light is broken, it triggers the electronic counter. Break the other light beam and the counter stops. For this vehicle to travel a distance of 1.5 metres, it takes 3 seconds. Average speed is distance, which is 1.5 metres, divided by time, which is 3 seconds, so the speed is 0.5 metres per second. To analyse the vehicle's speed in more detail, several light gates attached to electronic timers are placed at half-metre intervals. Now we can find out if the speed of the vehicle is the same all the way along the track. As the glider passes through the first gate, all the timers start. As it passes through the next light gate, the first counter stops. And then the second, and then the third. To travel the first half a metre, it took 1 second. Distance travelled, which is 0.5 metres, divided by time taken, which is 1 second, gives an average speed of 0.5 metres per second. The timer reads 1 second at the start of the next half metre. And 2 seconds at the end. Again, distance travelled is 0.5 metres and time taken is 1 second, so the average speed is still 0.5 metres per second. To travel the third half metre, it also takes 1 second. Once again, the speed is 0.5 divided by 1, which is 0.5 metres per second. So the average speed of the glider was constant all the way along the track. Plotting distance against time for a vehicle travelling at constant speed produces a straight line with a steady slope. A computer attached to the handlebars calculates the speed of this bike. Eventually, the cyclist is travelling at a constant speed. For speed to remain steady, the distance travelled in a given time interval must be staying the same. Increase the speed of the aluminium vehicle and the time taken to travel each distance will change. At 0.5 metres, the time from the start is 0.7 seconds. At 1 metre, the time is 1.4 seconds. At 1.5 metres, the time is 2.1 seconds. Increasing the constant speed of the vehicle produces a graph with a steeper incline. It takes less time to travel each half metre. What would happen to the time taken if the vehicle travelled more slowly?